So what we are doing here is we are combining two mixed numbers. And the reason that they are called mixed numbers is because we have 6 as a whole number and 3/4, which is a fraction. That's what makes it a mixed number. What you want to do is you want to change that to an improper fraction. So the way that you change that to an improper fraction is you take 4 and you multiply that times 6. So we get 24. Then we add that to 3. Okay? So this as a mixed number is 27 over 4. Because 4 times 6 is 24 plus 3 is 27. Okay? Now, we are adding, but I want you to look at this negative 2 1/2. Okay? Negative 2 1/2. This does cause confusion sometimes with students because of that negative. You need to think about that as negative 2 plus negative 1/2 or a negative 2 plus 1/2. Okay? That is a negative value. When you bring that negative sign down, forget about it anymore. Do you see how I pulled it down? So when you're changing this to a mixed or an improper fraction, you want to ignore that subtraction sign because you've already pulled it down. So I pulled it down right there. So then I have 2 times 2 is 4, plus 1 is 5. So that's negative 5 over 2. Now, I know some of you have already seen this before, but I've got several people from my 9 o'clock class in here. If I am looking at negative 2 1/2, and I look at that from the perspective of a decimal, that is negative 2.5. Okay? And it's also negative 5 over 2. So all of these, if I'm looking at a number line here, so here's 1, here's 2, here's 3. All of these fall right here on the number line. Now, the answer that students get when they do 2 times negative 2 is negative 4 plus positive 1, they get negative 3 over 2. And it is confusing. I understand that is confusing. But negative 3 over 2, it's right there on the number line. Okay? So think about that. Think about, okay, well, where would negative 2 1/2 fall on the number line? And the answer that I got for my improper fraction, does it fall at the same place on the number line? So that's what you want to think about. Now, another place that students are making some mistakes is when do I need a common denominator? When do I need a common denominator? We need a common denominator when we are adding and subtracting fractions. Adding and subtracting fractions. That is when we need a common denominator. When I am multiplying and dividing fractions, I do not need a common denominator. Okay? But here I've got 27 over 4 plus negative 5 over 2. I do need a common denominator here. My denominators are 4 and 2. Okay? So my common denominator, or my LCD, is going to be 4. The reason it's going to be 4 is because 4 goes into 4 and 2 goes into 4. That's why. So for my first one, I leave it exactly the same because it's already in terms of 4. So I don't need to change it. Okay? My second one, I do have to change it because it's in terms of 2. So I ask myself, 2 times what gives me 4? 2. Okay? And so because I multiplied the bottom by 2 to get my LCD, I also have to multiply my top times 2. Okay? Now, sometimes students get confused here because they do have to use their positive and negative rules, because we've got positive 27 over 4 and negative 10 over 4. We have that common denominator, so we can go ahead and write that common denominator down. And now I'm just adding 27 and negative 10. Which one has the higher absolute value? Good. And whenever I have different signs, I subtract. So what's 27 plus negative 10? Excellent. So my answer to this is 17 over 4. Please don't hesitate to stop me if you have questions. Your voice might be recorded, but that's it. Okay?
Oh, never mind. I have to answer.
Oh, you're good. Okay, you're good. Okay, got it. Okay, can I go to the next one? Okay. For the next one, there's a couple of different ways that you can do this. One of the ways that you can do this is you can get the LCD of all of them. Okay? You can look at 3, you can look at 2, you can look at 2, and you can look at 10. So you can ask yourself, what is the LCD of 3, 2, 2, and 10? And that means we need a number that can be divided by all of those evenly. Okay? So, if I had just these two numbers, if I had just 3 and 2, what is a number that can be divided by those evenly? 6. Okay? Now, if I add 10, how high do I have to go? So if I added 10 to the LCD, so if I wanted to find a common denominator for all of them, what would the LCD be of 3, 2, and 10?
No,
10 doesn't go to 12.
No.
It would be 30. Now, some students will say, well, why isn't it 60? 60 is a common denominator. It's just not the lowest. And once you get up into those numbers that are high, there's more opportunity for mistakes. So it's wiser to use 30, but it's not crazy to use 60. Yes, Jessica. You're good. Okay. I thought you were about to ask me a question.
No,
Now, some students choose to just find an LCD between these two. And that's reasonable, completely reasonable. And it's actually what I did because I could use 6 as my LCD. So that is what I'm going to do here. So I am going to make my LCD 6. And I'm going to say 3 times what gives me 6. And that is 2. My brain got ahead of myself. So 2 times 2 is 4. So I am saying that 2/3 and 4/6 are equivalent fractions. They are equivalent. Then I've got 2 times 3 is 6. So then I have 1 times 3 is 3. Okay? And when we subtract that, we get 1/6. Okay? Now, I'm going to work on the next one. I have 1/2 minus 7 over 10. What's my LCD for these two? 10. Okay? And it would be fine if you put all of these in terms of 30. That would be completely fine. Some people just like to work with those smaller numbers. 2 times 5 is 10. So then I have to do 1 times 5. Okay, so I have 5 over 10. 10 times 10, or 10 times 1 is 10. So I leave this one the same. Okay? Now be careful here. 5 over 10 is still positive because we're dealing with what's inside the parentheses. Okay, so I actually have 5 over 10 minus 7 over 10. Okay, what's 5 over 10 minus 7 over 10? 2. It is, and is it positive? It'll be what? It will be negative. Once we subtract it, it's 2, but it is negative because negative 7 has the higher absolute value. So negative 2, okay, hold on. Negative 2 over 10. Okay? Now, don't forget, we are subtracting. So we are subtracting. So now I've got 1 over 6 minus negative 2 over 10. Now, I've got a double negative, so that's plus and plus. Does 2/10 simplify? Is there any number that goes into 2 and 10?
Yes.
It's 1/5, okay? 2 goes into 2 one time, 2 goes into 10 10 times. So you may choose to go ahead and simplify that. If you don't simplify it, it's fine. You're just using 60 as your LCD. If we do simplify it, what can we use as our LCD? Good. Good. 6 goes into 35 times. 5 times 1 is 5. 5 goes into 36 times. 6 times 1 is 6. We are dealing with positive numbers here. So my final answer is 11 over 30. Now, if at this point right here, you did not simplify, that is 100% okay. If you did not simplify at this point right here, that is okay. We are going to have a common denominator of 60. Okay, 6 goes into 60 10 times. 10 times 1 is 10. 10 goes into 60 6 times. 6 times 2 is 12. You get 22 over 60. What goes into both of those? What goes into 22 and 60? They're both even, so what does that tell you? 2. Okay, so if they're both even. So this simplifies to 11 over 30. Okay, yes, sir?
You changed the negative to the positive.
Sure.
Why did you do that?
Okay, good question. So I'm going to go back to right here, right?
Yeah.
So this was minus negative 2 over 10. Okay, so we have minus a negative. When we have subtraction of a negative, the rule is we change our subtraction sign to addition. We make the next number its opposite. Okay? So what is helpful to students is whenever they see that double negative like that, they change it to a plus. And that is why. That's a great question. I did have a student in one of my classes come up and ask about this question. And the question was, okay, do I get a common denominator and then just drop the parentheses? And I said, well, that's okay if you do it that way, but what would have to happen with that negative right there? What would you have to do? We'd have to distribute it is what we'd have to do. So dropping the parentheses in this particular thing really isn't the best method to use for that. But it is an option, but you have to distribute that negative. So I wouldn't just drop the parentheses. Okay, is it okay if I go to the next screen? Okay. Okay, now this is kind of a soft exponent because we've only got a couple of things going on in here. One of the things that I want you to remember that if you have a negative number and that negative number is squared, that means raised to the second power, you are going to get a positive number. Okay? Now, if you have a negative number and that is raised to the third power, you're going to get a negative number. Okay? And let's talk about why. So what I'm doing right now is I am taking this negative 4 squared and I'm looking at it right here. Okay? My negative is being squared because it's inside the parentheses. So what this means is negative 4 times negative 4. What is negative 4 times negative 4? 16. Okay? So I'm going to have 3 times 16. Okay. Now I am taking this negative 2 to the third power. Okay. Negative 2 to the third power. It means negative 2 multiplied by itself 3 times. That's what that means. So I have negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4. And then I've got that negative 2, so I get negative 8. So if you've got a negative number raised to the second power, you're squaring it, you're going to get a positive number. If you've got a negative number and you're raising it to the third power, you're going to get a negative number. Okay? 3 times 16 is 48. If you don't have that memorized or you don't look at that and see 48, you can do 16 times 3. 3 times 6 is 18. 3 times 1 is 3, plus 1 is 4. Okay? 5 times negative 8 is negative 40. Okay? I have a positive number and a negative number. Which one has the greater absolute value? 48. So is my answer going to be positive or negative? Good. It's going to be positive. 48 is further from 0. I think what you're remembering is you're remembering multiplication rules. Okay? So a positive times a negative is always a negative. And so I think you're getting the multiplication rules confused with the addition rules. That would be my guess. Okay? 48 plus negative 40, my answer is going to be positive. I subtract their absolute values, and what do I get? 8. Okay. Can I move to number 4? There's a lot going on in number 4. I would probably say it's the second hardest. That's what I would say, is it's the second hardest. So, what you have to remember about this one is you have to do exponents first. You have to do the exponents first. And students want to do things, they want to kind of get rid of things and start multiplying. Don't do that. Do the exponents first. So I've got 2 to the third power. That's 2 times 2 times 2. What is that? 2 times 2 times 2. Okay, you added. You added, which is fine. You're fine. And 16 is 2 to the fourth. So it's 2 times 2 times 2. 8. Good. Good, good, good. Okay, so that is 8. Then I've got my plus 3. Then I've got negative 1 to the third power. That's negative 1 times negative 1 times negative 1. It's a negative number raised to the third power. It will be negative 1. What were you saying? No, you're good. You're good. It's a negative times a negative times a negative. So it's going to be negative. Okay. So I have gotten rid of that exponent, but I still have the negative 1. Then I have negative 2 squared. What's negative 2 squared? It is 4. It's positive. Anytime we square a negative number, we get a positive number. Okay? So this is times 4. Okay. Then we have minus 5 times negative 1. And here's another exponent. What's 2 squared? 2 times 2. Good. Okay, now, what I tried to do is I wrote the stuff in red that we had to deal with first. So we had to deal with all those exponents first. The purple is what we didn't touch that first walk through. That's what the purple is. It was just part of the original equation. Okay, now our next walkthrough, what we're going to do is we're going to focus on the multiplication right here. Okay, you see that multiplication? And then we've got multiplication right here again. Who does this minus sign belong to? Good, it belongs to the 5. Okay, so I'm just going to bring the 8 down. Then I've got 3 times negative 1 times 4. 3 times negative 1 times 4.
That'd be minus 12.
It is minus 12. Good. Okay. Now I have negative 5 minus 1 times 4. So actually I'm going to re-say that. Negative 5 times negative 1 times 4.
So you don't bring down that plus sign?
The minus sign?
I thought it was 8 plus 3. Like,
Oh, yeah, you can. And then this would be 8 plus negative 12. Yes, that would be fine to do it that way. 8 plus negative 12 and 8 minus 12 are exactly the same thing. Okay? Now, students at this point do things a different way. A lot of times students will just add and subtract from left to right, which is correct. Addition is commutative, and that means we can change the order if we're down to addition. We can't change the order at the very beginning because we got all sorts of things going on. If you wanted to add the 8 and the 20 and get 28, that is reasonable because they're both positive. Some students like to do it that way, but you don't have to. So 8 plus negative 12, that's going to be negative 4. And then we've got plus 20, and that's going to be 16. Okay? So I would probably say that's the second hardest on the assignment that we just did. I would say that was the second hardest.
But you can do 28. 20 plus 8 minus 12 is 16.
Yes, absolutely. As long as you've got only addition and subtraction left. Good job. Okay? Can I go to the next one? You good? Okay. Now, we've now jumped from computation to where we don't have any variables at all to simplifying. So you kind of always look for distributive property when we're simplifying. So here I've got 5 that I've got to distribute. Okay, and then I've got a 7 that I've got to distribute. 5 times x is 5x. 5 times negative 1 is negative 5. 7 times x is 7x. 7 times 4 is 28. Now, 5x and 7x are like terms. They are the same variable. Okay, so I can combine those and I get 12x. Then I have a negative 5. That subtraction stays with that 5. If you move these around, the minus has to stay with the 5. You can think about it as plus negative 5, but the 5 is negative. Negative 5 plus 28, they're opposite signs. So we're going to subtract. And is it going to be positive or negative? Excellent. Okay, and when we subtract, what do we get? 23. Now, number 6, I think I accidentally tricked everybody because students wanted to make it much more difficult than it was.
yeah.
Okay, so I was like, wow, I didn't really mean to do that. So here we've got negative 3a squared plus 7b squared plus 9a squared minus 2b squared. Okay, the only thing that we can do here is combine like terms. We don't have anything that we can distribute We also do not have anything that we can raise to a power, because the only thing being raised to powers are our variables. And I'm going to show you what that would look like if we were raising numbers. So I've got negative 3a and positive 9a. Okay? Negative 3a squared. I'm sorry, I didn't say squared. Negative 3a squared and positive 9a squared. That's going to give me 6a squared. Then I have 7b squared and negative 2b squared. Okay? And that's going to give me 5b squared. Now, this is what several students thought I was saying. Several students thought I was saying negative 3a squared plus 7b squared and on. Okay? What is difference between my red negative 3a squared and my purple, which is part of the original problem, negative 3a squared? What's the difference there?
This is a
Oh,
it's not.
good. And how in the red do I show it's together? What did I put around it? Parentheses, okay? So that 2 in my original problem, it only belongs to the A. And that 2 only belongs to the B. So my A is being squared, my B is being squared, my A is being squared, and my B is being squared. But if I wanted to square numbers, this is what it would look like. And that was not what I was asking. Okay? So I always learn stuff when we do classwork. Okay. I like this one because we have to distribute a negative. I like this one because we have to distribute a negative. So I do 3 times 2x, that gives me 6x. 3 times negative 5 is negative 15. And most students do fine with that. It's this minus 4. Remember that subtraction sign belongs to the 4. So I am doing negative 4 times 5x, and that's negative 20x. That right there is where students miss. The negative 4 times the negative 2 is positive 8. Okay? And students oftentimes miss that negative times a negative. So just be sure you're distributing that negative also. Okay? I have 6x and I have negative 20x. Okay? 6x and negative 20x. One's positive, one's negative. Negative 14x. Good job. Okay? And then I have negative 15 and positive 8. Good. Negative 7. Okay, are we ready to do everyone's favorite one? Okay. When students came up and asked me about this particular one, I would kind of look at what they were doing, and then I would say the same thing to everybody. Simplify this problem first. Do number 8 the same way you did 5 and 7. And that is what I would encourage you to do on Friday with the prep assessment. Simplify it first, then plug in that negative. Okay? So here, I'm going to ignore that x equals negative 1/2. I'm just going to ignore it. I'm going to do negative 3 times x and negative 3 times 1. So I get negative 3x minus 3. Okay? Now, I am distributing a 4 to a negative x, and that's weird. What is 4 times negative x? It's negative 4x. Good. Then I've got positive 4 times negative 2. That is negative 8. Then I have negative 3 times negative x. That is positive 3x. Then I have negative 3 times positive 4. Okay? Now, at this point, I would have some students come back to me and say, okay, I simplified. But is this completely simplified? No. I have multiple like terms. So here, I have negative 3x, negative 4x, and positive 3x. Now, do you see how I've got a negative 3x and a positive 3x? What do those equal? 0. Okay, so just mark those out. If you've got opposites like that, mark them out. So now I'm only left with negative 4x. Okay, I've got minus 3, minus 8, minus 12. They are all negative. Negative 3 and negative 8. We're adding absolute values because they're all negative. What's negative 3 and negative 8? Good. Negative 11 plus negative 12. Negative 23. You were very, very close. Negative 23. Now, yes, question.
So when I was doing it in class, I guess I did 10 over 1, but that's because I added the like terms. And my brain didn't tell me to just, negative 3x, positive 3x, cross them out because they're going to cancel each other out.
So wait a second. You got negative 10 over 1 for the answer or for?
No, well, so I had 10x plus 1, so I added negative 3 and then negative 4.
Okay, so somehow no, I know what you did. I know exactly what you did. So you've got negative 3x and negative 4x, and you got negative 7x, which is correct.
Mm-hmm.
Do you have plus 3x or negative 3x up there?
And then I have plus 3x.
Okay, so what you did to get negative 10x is you treated that 3x like it was negative. You just added all their absolute values together, even though you had different signs.
Okay.
That's what you did. Yeah. See, I got it. I can figure out where you messed up. Okay. So now I'm going to bring this negative 1/2 and put it in. So I've got negative 4 times negative 1/2 minus 23. Now, the most common mistake I saw here was people trying to make this negative 4 over 1 times negative 1/2 into a common denominator. You don't want to make it a common denominator because we're multiplying. When you multiply and divide, it's way easier than adding and subtracting. All I need to do when I'm multiplying is say negative 4 times negative 1 is positive 4. 1 times 2 is 2. Okay? 4 over 2 simplifies. What does it simplify to? 2. So then I have 2 minus 23. And so my final answer to this is negative 21. Now, you totally can do it the other way, but it is much more painful. Much, much more painful. Yes?
Why do you do 2 minus 23?
Okay, so are you with me right here at the negative 4x minus 23?
Yeah.
Are we good there? Okay, so what I did next is I took out my x and I put in the negative 1/2. So when I multiply negative 4 times negative 1/2, I get 4 over 2, which simplifies to 2. Okay? So are you saying you think we should just leave it as 2 minus 23?
Oh, no, I just didn't realize you simplified to 2.
I gotcha. Oh, why 4 over 2? I got it. So you missed, okay. 4 over 2 is 2.
Yeah.
That's how we got to that. Good question. Good question. How are we about that? Okay, good. Good. Can I go off this screen? I know some of you might still be writing. Okay, number 9. And what is my values? X is 2. Y is negative 2. Okay? There's nothing I can simplify or anything here. Like I've got to go ahead and plug stuff in. So I have 4 times 2, and I am squaring that, minus negative 2. Okay, so I have taken my x out and put a 2. I have taken my y out and put a negative 2. Now, yes?
Okay, so would it be like a difference if you would put like 2 inside the parentheses? Like,
Okay, so you're saying, could you write 4, 2 squared like that?
yeah.
Okay. On this one, it's fine. On this one, it's not okay. Okay? Because if I do negative 2 squared inside the parentheses, I'm only telling the 2 to be squared, not the negative. And I want the negative and I want the 2 squared. So when it's negative like that, it has to be on the outside. Okay? So my thought is just put everything in parentheses. And I think that helps. Now, one of the things that students might want to do with this that is wrong, do you see how I have that double negative right there? I can't cancel that double negative. I can't cancel it yet because I haven't dealt with the square. When I cancel that double negative, that's along the lines of multiplication because it's really negative 1 times negative 1 is what we're doing there. But what comes first? Exponents. So I can't cancel that double negative because I haven't evaluated negative 2 squared yet. So I have 4 times 4, because 2 squared is 4, minus negative 2 squared. Yes, okay? So so the correct step here is 4 times 4 minus 4. That's the correct step. If I canceled out that double negative, I would have 4 times 4 plus 4. So you've got to do that exponent first. So then I get 16 minus 4 is 12. Okay? A lot of what I saw on the next 3 problems, students were doing super well. I think I have to erase. Yep. Okay. Okay. Less than. So I've got 4 less than 1/2 a number. Okay? 4 less than. So we know that the word 4 is going to be the number 4. Okay? Less than is subtraction. Less than is subtraction. Now, anytime you see the less than, 4 less than, that means I am subtracting 4 from something. Okay? Now, some students will want to put that 4 first. Now, if it said the difference of 4 and some number, then you would put the 4 first. But when it says less than, you are subtracting 4 from something. Now, how do I write 1/2? Good. And this just says a number. So what can I write for a number?
N.
Yeah, you can write N, you can write X, you can write A, you can write whatever you want. Okay? So this is 1/2 of a number minus 4. I had several people write it like this, and that's correct. That's absolutely correct. So either one of those is fine. The trick is being sure you've got that less than. 4 less than means subtraction. Okay? I've got to erase the next screen. Can I go to it? This one's a little bit of a challenge because we have a couple of different things going on. 10 times. When I say 10 times, what operation am I doing? Multiplication. Okay? So this right here means 10 times something. Okay? We don't know what that something is yet, but it's 10 times something. Then I've got the difference of a number and 6. The difference, and difference means what? So of a number and 6. So the difference of a number and 6 is just n minus 6. The thing that students forget is the parentheses. Okay, that n minus 6 is a unit by itself. So we have 10 times n minus 6. But a lot of people did very well on that. Very well on that. Okay. Our last one, Brian. Brian is n years old today. How old will he be in 20 years? Okay? So if I am 46 today, what am I going to do with that to find my age in 20 years? Add 20. Okay? Add 20. So if I'm not 46, how old am I? Or how old's Brian? N. Okay? So that's n plus 20. Okay. I'm just going to give you a couple hints. Make sure your homework in WebAssign is finished. Make sure your homework in WebAssign is finished. And then look over this classwork assignment. Look over this classwork that we did today. Okay, if you know how to do the classwork, you're going to do great on the prep assessment. Okay? And we won't have a help session on Monday because we are not here. But we'll have one next Wednesday.